Children, again you may observe that a limit is scattered, but here thing is different. In place of giving you inequality, they have given equals to and not equals to. So what we have to do? So for that, and again observe in a question they have given a modulus function. So whenever they will give a modulus function, so that time we have to use a definition of a modulus function which you have studied in second chapter, that is relation and function. So first of all I have to define modulus x, that is modulus x, if I will remove modulus, it can be positive and negative. See, so if positive value or negative value in a modulus will give a positive value. So modulus can be of two different things. Positive x when x is greater than equals to 0 and negative x while x is less than 0. This definition is given in a second chapter. Now see, we have to find limit at point x is equals to 0. Now while limit is scattered, obviously we have to check left hand limit, right hand limit and f of a. So if all three are equal, then only we may conclude. So here f of 0 at 0, that is 0 given. So first of all we have to check at left hand side, at right hand side. Though it is not equals to given, so left hand limit and right hand limit function will remain same. So here first of all left hand limit we will calculate. So while we are evaluating left hand limit, so that time x is equals to a minus h. Our a is 0. So here we have x is equals to 0 minus h. As x tends to 0, h tending to also 0. In place of x we just have to substitute 0. You may observe minus h is equals to 0, that is h is equals to 0. Now our function limit x tends to 0 minus. Why 0 minus? Because it is left hand limit. Sorry, by mistake I have written as it is left hand limit. So f of x, which is equals to limit x tends to 0 minus. Our function f of x, this one, modulus x upon x. So modulus x upon x. Now we will convert it in terms of h. So which is equals to limit h tends to 0. In a modulus, in place of x we will write down 0 minus h upon 0 minus h. Now limit x tends to 0 minus. Left hand, obviously less than part we have to take. So outside the modulus it is minus. So in place of minus h here, that function upon minus h. So which is equals to, okay, here also 0 will come, by mistake here I have written h. Now observe, again in your mind will be a question, madam here written a modulus, so outside the modulus it should be positive. Yes, your argument correct. But here we have defined modulus function that if we are working towards RHS side, so this value will remain same. But outside the modulus will take this sign. So minus h will remain same and outside the modulus it will take minus sign. So now minus minus will be positive. So here we have minus 1. So limit h tends to 0 is minus 1. No variables, you cannot place any limit. So here now right hand limit. So while you are taking right hand limit, x is equals to a plus h. So here I am taking a plus h. But here Ra is 0. So 0 plus h. As x tends to 0, h also tends to 0. Now how I am taking this limit? Hope now it is understood to you. So limit x tends to 0 plus f of x, which is equals to limit x tends to 0 plus your function, that is modulus x upon x. So which is equals to, now we'll convert in term of h. So in place of x we'll write down 0 plus h, that is h only. So modulus h upon h. Towards positive part it is positive only. So sign will not change. So here we'll write down limit h tends to 0 plus h upon h. Both will be cancelled out. So we have 1. You may observe that left hand limit we are getting minus 1. right hand limit we are getting 1 and f of a we have 0. So you may conclude that LHL is not equals to RHL. Therefore limit does not exist.